Welcome to Athens Kubernetes Meetup. Today we have two talks. The first one from Stavros is a fairy tale about some Argonauts and stuff like that. The second one is from Alessandro. He's going to tell us about Gateway API. But first, some words from Dimitra that represents our sponsor, Morotech.
Thank you very much for the introduction, and it's really nice seeing you all here. We're super excited to host another Athens Kubernetes meetup. So, first of all, my name is Dimitra. I am part of the People and Culture team at Morotech. I work in talent acquisition, mainly for tech and product roles. So I'm going to take just a couple of minutes of your time to briefly introduce the company, who is Morotech, and what is our business. So first of all, Morotech is a technology-enabled consultancy company, and we offer business transformation solutions for various clients, mainly in the mobility industry. We have a variety of domains that we are working on, and this includes. This includes mainly two big domains. From one side, we have the strategy consulting, in which our consultants and mobility experts, by providing actionable insights to our clients, they help them shape their product and business direction. While on the other side, we have digital solutions. In this area, our tech and product experts help implement technical and data-driven solutions based on each client's needs and goals. Our main clients at the moment are mainly big players in the automotive industry sector that will support their growth and business needs. As Morotech, we are also part of the Moro global group of companies, and we have presence in various countries inside and outside of Europe, for example, Japan. So this has allowed us to adopt the location-agnostic mentality. It also allows us to work in an international and multicultural setting. So besides the benefits that the location-agnostic approach allows us to provide to our members, for example, remote working and flexible working hours, we are committed in providing a positive working experience for everyone. So we offer a variety of other benefits, including learning and development budget for its members' needs, and even additional days off. We are also a company that grows quite fast. In 2021, we were only 17 people. Right now, we are close to 100. Of course, we continue to grow. Regarding our structure, the majority of our people are in the software engineering department. In this department, we have a variety of chapters. For example, we have several chapters for DevOps, for data, for application, and agile delivery, among others. And while all of the people have the opportunity to work in cross-functional teams, so they can work and collaborate with people from different crafts. Besides engineering, 14% of our people are in the product department, 15% in strategy, and 13% in other functions, like, for example, marketing, people and culture, and operations. This is a quick look of our stack. So we have a quite variety of tech stack. We mainly use Java, Python, and JavaScript for our web applications, and everything is hosted on cloud, and specifically AWS. You can also scan the QR code behind me if you want to check our open positions, or of course learn more about Morotech. And of course, the people that on site today will be around, so feel free to stop us and ask any questions that you may have. That's everything. Thank you.
Stavros?
Thank you. Hello. So yes, hello, my name is Stavros. And it works, yes. I started my career as a full stack. As a full stack developer, I have some experience with network automation visualization, DevOps, Kubernetes, and right now I'm part of the engineering productivity team at Elastic, where we are trying to make everyone's life easier. So, yeah, what we're going to talk about today. Practically, we're going to talk about how CD has evolved at Elastic, how we're using existing open source tooling, how we filled any kinds of gaps that we found, and well, the future. So yes, how it all started. We tried to, practically when we decided a couple of years ago to switch to using Kubernetes, we wanted to deliver a system that would help developers push their code and deliver it to production. We wanted to keep everyone happy. The developers would need an easy way to do that. The operators did not really care to do the deployments per se. Then users wanted a stable product. Any issues should be deployed and fixed as quickly as possible, and of course that infrastructure could be recreated, new infrastructure added for capacity and automation. So yeah, let's talk a bit about terminology so that we can all understand. Anyone who's not familiar with Argo CD? Okay, so briefly, Argo CD is a tool that is looking at some Git repos, and is also looking at the state of a cluster. And if it finds any differences, it makes sure that the cluster is synced with what's described in Git. Yes, and practically, I'm going to talk a bit about Argo CD applications, which is practically the configuration that Argo CD accepts to understand which repo to look at, how and where the content of this repo should be deployed. So yeah, an Argo CD application is practically a YAML file that includes all this information. I guess I just also described GitOps. It's this process. I'm going to talk a bit about deployment environment, which is an environment where you host your services, either QA, staging, production. Anyone who's not familiar with Customize? Okay, so Customize is a way to do some kind of templating in YAML, specifically for a Kubernetes manifest. So let's say that we have a pod, then but you need the same configuration, almost the same configuration in different formats. Then you can use Customize to use a base template and then alter only the attributes you'd like for its given cluster, let's say. Qlang. Okay, I'm just going to go ahead and describe. Yeah, Qlang is a tool, let's say, that accepts some kinds of input, YAML mostly, or JSON, and you can do some, you can add some, not too much, business logic to change the input to something you define. So it's mostly you create different kinds of objects based on the input you get. And Backstage. Okay, so I'll explain that as well. Backstage is a service catalog. It's let's say a piece of software where you can register the services that your team manages or other teams manage. So that, for example, let's say that I want to maintain a service. then I can declare that the service has a repo that hosted there, or that it needs also access to something else, or I can declare that, let's say that the CI pipeline will be X anyway. So anyway, it's a way to describe a service or more services and how they're connected. It doesn't matter that much in this context. So yeah, let's talk a bit about continuous delivery. Continuous delivery means that practically, if I'm a developer and I maintain a service, I want, as soon as I merge this service to this exchange to the main branch, I want it to go to production as quickly and as safely as possible. And yeah, practically for us, back then it meant that we would use Argo CD, which is kind of the industry standard to, when you're using Kubernetes, a Git repo where we would store the configuration that would describe how the services will be deployed. And whenever this Git repo changed, then Argo CD would know it, and then it would deploy. It would make sure that QA or the target environment in general would reflect those changes. We wanted, and after that, the developers would check that the service is working fine, and when they were confident enough, they would make their respective change to deploy to the next environment, which meant, yeah, I didn't say that the whole Git repo was using Kustomize, because it was a lot of, it included a lot of repetitions, because probably the deployment of a service in QA was almost the same as staging or production, but one little variable would change. So it didn't make sense to write the same exact manifest 2 times for only that small change. So we decided to use Kustomize. Yeah, as you can understand, it's not easy, it's not maintainable. So as a result, yeah, it looked like this. The developer would go to change the application set as soon as they felt that they wanted to push a change to an environment. Then after they merged, Argo CD would detect the change and provision it. So yes, the developers were not happy. We were not happy as well. So yeah, they were not happy because of a lot of manual work that they had to do. They were super confused by having to use Kustomize. Yeah, anyway, so Kustomize, as I said, included directly Argo CD applications, which meant that if a small little detail was a bit off, then we would have to debug. Practically, they would be confused, they would ping us, we would have to debug and explain what the issue is. And nobody was confident that, you know, the change that was deployed in an environment was really working, apart from the person who tested. And you know, some days you're not really eager to test, so it was really error-prone anyway. So yeah, we had to think. We had to think a lot, and we decided to yeah, to solve the easiest problems first, let's say. So the way we saw it back then, the easiest step would be to, instead of having the developer to change directly the version of the service on the GitOps repo, maybe we could do it. So practically, the last step of CI would be to update automatically the GitOps repo, which meant that as soon as a change was merged, a service change was merged to their repo, a CI would provision it, and the developers would expect to see the change soonish to the QA environment. Yeah, we were using, as I mentioned, we were using Backstage. So whenever they didn't have to create the application from scratch when they wanted to introduce a new service, because they could just create the service definition from Backstage, and then they would see the default configuration on their repo and on the GitOps repo as well, automatically. So practically, okay, this became like, it's not easy. Yes, this. So practically, we're using build-guide for CI. As soon as CI finished, it would instead change the configuration. Argo would detect that, and it would provision the changes to the clusters. Well, so yes, nobody was happy still. Many changes needed to happen. The developers, yes, they were happy because they didn't have to go to change the applications, the GitOps repo on every change. But still, if they wanted to change any flags, using customize was not really easy for them. Same for the Argus, the apps. Nobody was confident as well. So we had to think more. Yes, and what we decided is to create an interface where the users would only provide the things they needed, which is where we started using from this. We started using a couple of other components. We started using QLang. We also introduced Argo workflows, which is let's say a way, it's part of the Argo ecosystem, and it's a way to run jobs on a cluster. That's pretty much it. So build guide, instead of just directly making changes in the repo, it would trigger a workflow which then, for starters, would just update the version of the service on that YAML input, and then Q would generate the application configuration so that Argo knew how to deploy each service. So yes, we had eliminated most of the problems, apart from the most important and most difficult, because still we didn't have any ways to check that, or the developers did not, and we did not provide any ways to the developers to check if their service works as expected, and we needed to do that. So yes, let's talk a bit about trust. How do you trust a change? How, I don't know, what's the smallest amount of change you can trust for production? I guess none, I don't know. Yeah. We wanted to figure out.
Can you tell a bit more about the previous slide? I think
Yes, I mean, it was a small change, right? It brought half of the internet down, so. Yes. Making sure that the change you're trying to deploy, is like important. So yeah, we wanted to figure out what that means, how to make sure that that we provide all the tools for the developers to feel confident that what they are about to deploy works as expected. So we try to provide them a way for them to make sure that, let's say, as an example, that you deploy a service, then you have created a couple of or more SLOs that you monitor, and you don't expect them to go off after the deployment. If they do, then probably something is a bit off with your deployment. Of course, we enforce unit tests, integration tests. Lately, we have also synthetic testing. Some teams wanted to take their time, do some manual testing, and do some manual approval. That can work as well. Some bake periods, some teams even wait for a week before moving to the next environment, which is painful, but it is what they want. So that's what we're here for. Okay, so in general, the release process, like briefly, is that we have some developer makes a change, they merge to the main branch, CI gets triggered, then it triggers the CD, which is updating Git with a new chart version. As soon as Argo CD picks the change up and deploys it, then we trigger some tests, whatever that may mean for every team. So each team defines the test they want to make sure that they're confident. As soon as everything is fine and no check has failed, then we do the same for the next environment. So practically we will trigger CD again with different arguments until we reach production. And it looks like this. If you want a different visualization, build kite triggers Argo workflows, which updates the YAML, which then is rendered to Argo CD applications using Q, which deploys to Kubernetes, and then as soon as the deployment is finished, then we call them quality gates. The quality gates are running against that cluster or that bunch of clusters. And depending on the results, we notify the users that your deployment was fine, we're moving on to the next environment, or your deployment was not fine, we're logging the specific service on the specific environment until you resolve it. We also keep some data in Kibana so that we can provide the users with some dashboards, which I'm going to show a bit later. And yes, that's pretty much it. So yeah, let's talk a bit about how the users are exposed to what I just explained, and yes, and what's their experience with using all this tooling. So practically, a developer, all they need to do is to go to the service repo, make any code changes they want. On that service repo, yes, also includes the Helm chart definition. So practically, along with the code, we have bundled the way to describe that service on Kubernetes and the Docker files as well. And they also need to go to the GitOps repo, make any changes, as in defining where they want the service to be deployed and how. What kinds of checks they want to do and stuff like that. So then our automation picks it up until it reaches production. At the same time, they have the deployment dashboard and Slack messages so that they can know what's up with service deployment. So briefly, I'm going to show you what they have to do. Let's say that I am a developer and I want to create a new service that prints hello world, whatever. I go to Backstage, I choose to create a new service. As soon as I fill a form with some basic info, I get my repo with all the boilerplate and with a structure that makes sense and is consistent with every other service. A CI pipeline already defined, a new entry on the GitOps repo as well, dedicated to that for that service. So on the GitOps repo side, a service definition looks like this. My Hello World service is owned by Team A. I'm part of Team A. Team A rocks. The source is the name of the repo where the source code lives. The chart, which this code is included, is on that path in our internal registry. The type means that it will only be applied, will only be deployed to the application clusters, whatever that means. So it's a subset of our infrastructure. On these three environments, the QA and production, on that namespace. It's a bit simplified, but you get the gist of it. And this is how the service is going to be pushed to these targets. Practically, you define which environments would be deployed directly after CI passes. So, for example, the dev environment, yeah, it's a good candidate for direct promotion after CI works. We can define some quality gates, which practically here we are triggering a build kite pipeline, which is important because the developers are familiar already with build kite because it's their CI, so it's easier for them to write some tests against a real infrastructure and some other parameters. This is how you define the versions. It's as simple as that. Not you. The automation does that. So practically, whenever, let's say that you have updated QA and all the checks have passed and it's time for you to move on to staging, practically what would mean for our automation is that this entry would change with a new hash. That's all. And that would trigger the ending of queue and the deployment to staging and the triggering of the quality gates. You get the idea. And this is the layout of the user repo, the service repo, of this hello service repo I just created. We care about three things. One is the build kite directory, which is the CI. The Helm directory, which is the definition of the chart. First, it's almost empty. It has some helpers for the developers, and the Dockerfile.sh, which is respecting some environment variables that can be passed, so that we can dynamically add some stuff. It's out of the context of this presentation, so I will not go into that. This is also auto-generated. This is the CI. We try to make it as simple as that for the developers. There is one command to package a Helm chart. They don't really care, it's there. They just need to not touch it practically, unless they have to, which we're going to help with that. We build the images, and I'm saying images because we need more than one architectures, which is kind of tricky, but we're there for the developers, so they don't care. And the very last step of their CI would be to trigger another pipeline, which is just a curl request, which is starting the deployment process on our workflows. This is the deployment dashboard I talked about earlier. This is what, if a developer is wondering, how's I think I committed a couple of hours ago. What's going on with my service? I don't have any notifications on Slack, so it's probably doing well. They can go to Backstage, look at the dashboard, which is practically being generated by data we gather from Argo. We put them to Kibana and with the help of Argo events for the record. And then we're using this data to create this dashboard. So they can see that, the version of the service that they merged is verifying on environments MKI, or the change that they merged yesterday, for example, hasn't reached production yet. It's on Canary. So yeah, of course they can see more details on that, but that's the gist of it. And I think, yes, from our point of view, yes, I can't complain. It could be worse. We definitely get a small amount of questions in our daily work around the deployment process. Mostly, it's people, when they want to do some more advanced stuff, they're confused about, because there's a lot to digest in here. So yeah, we have to deploy to explain how it works. So from our standpoint, a big problem that we had at some point is that we had to deploy everything at once per environment, which meant that a service change was made, we would deploy the whole QA with that change, and then we would go we would do the testing. Of course, we would go to staging and then do production, the whole production at once. So yeah, that's not like great. So we decided to do it gradually, and we had to make a couple of tweaks. It's not easy to do, but we made a couple of tweaks, and it's very transparent to the user. Admittedly, they can just define the number of practically the strategy, like if they want to deploy the service in 5 equal chunks in production, or like follow something much more conservative, like first do, let's say, 2% of the clusters, then 10% of the clusters, and so on and so forth. So they just define that, and then we generate everything using Q, and then we know how to handle it. Then the number of clusters and applications managed by a single Argo-CD instance, since we are kind of a big scale, on a big scale. So right now we have around 1,000 Argo-CD applications on around 50 clusters, and we haven't. This offering is not really released in public, so. Yes, we had to plan on how to go about it in case we reach the limits, which the obvious solution is to shard Argo, which meant that we would need to redistribute the clusters and how we're going to do that, and some logistics anyway around that, which we have almost finished doing. Also, I mentioned that we render Q, which takes about 5 to 10 seconds, and we're doing that on Argo-CD, which means like a lot. We have a change on our GitOps repo every 5 to 10 minutes, so now it's not a problem, but it will soon become a problem, unless we support multiple GitOps repos, which is a different discussion. And one of the biggest problems we've seen is that, as I mentioned, we have some wait periods of 7 days, which means some Argo workflow pods, some deployment jobs, let's say, would be running for 7 days, and we don't keep state anywhere else apart from the pod, so they could not be killed, which is kind of against the rules of the whole concept. So, for example, I tried to do a node upgrade, and the node upgrade did not happen because 20 minutes have passed and a pod was still running. So it practically would kill the new pod and remigrate all the other pods back. So we had to handle that, which was kind of fun. We definitely need to revisit that in the future someday, my friends. Yeah, we have a lot of SLOs, observability, dashboards. We're part of Elastic. So yeah, thankfully we have good tools to give us insights. And this is a small part of our Argo-CD dashboard. And they've been helpful for us to understand quite easily what the problem is. Thankfully, we didn't have a lot of incidents until now. Fingers crossed. Yes, I know it's a lot to digest, and thank you for staying with me. So yeah, questions? Yes.
Can you expand a bit on the role of the addition of Argo workflows?
Yes.
Is it the same thing?
I couldn't get
Why would you make the same operation?
with the.
Can you repeat the question?
Yes. The question is, why did we decide to move away from build kites and introduce Argo workflows? So it was easier for us to practically, Argo Workflows is part of the Argo ecosystem. It doesn't say much in that context, but at least we knew that we would leverage Argo Workflows for different other purposes other than CD. And at the same time, a small, allow me to say, shitty bash script that I wrote it, that's why I'm allowed to say these things. So was running on build-kite, and it was really small because it would only just do a commit on some repo, started growing a lot, which ended up in a Go binary that is like more than 2,000 lines, because inside there we needed to fit the triggering of the workflows, the waiting for the deployments and stuff like that. Yes, we could run the binary build-kite, but it felt easier to do that on our own infrastructure and closer to Argo CD.
Thank you for the presentation. I was wondering, you told us that you put some effort into visualizing Argo CD graphs through Kibana to the backstage dashboards. So your developers don't have access to Argo CD at all?
They do, but it doesn't provide. No, sorry. So the question is why was there a need of a dashboard practically?
In backstage and not in Argo if the developers already have access.
Exactly. If a developer has access to Argo, they can see what's up with their service, which is correct. But at the same time, what they can see in Argo is the current state of things, and which is it's not exactly the same in the dashboard. It is what I showed, indeed, but storing the data in Kibana, we can move back and forth in history, so we can see at any given moment what the state of the deployments was. And we're trying. We do have the developers do have access to Argo, but we're trying to help the developers stay focused in one place, let's say, which is why using Backstage seems like a good idea.
Hi. So, quick question. Are you using the applications pattern?
Yes, the question is if we're using the application of applications pattern, which, so yes, let's go a bit deeper. Let me see, I have this thing. Sorry? Yes, yes, yes. It wasn't easy, but I'll explain. Let me see if I explain this a bit more here. No, I don't. So I'll leave it here if you want to see more details. But the AppOfApp patterns, for those who don't know, is that you need an entry point for Argo CD so that it knows which repos to look at. And then, in turn, practically a repo would include Argo CD applications that would point to other repos that would point to other Argo CD applications, and so on and so forth. The way we made it work for us, because there's a lot of recursion in there, is that we are using Q, because as you might have guessed, we're using Q for the developers to provide the information they want, and then we use the Q scripts to generate a lot of application sets, one per service specifically. And then these application sets would generate applications based on the labels of the clusters that they matched. And then these applications would point to their respective repos. So practically there's thankfully only one layer per environment. We have one app of apps, one for dev, one for QA, one for staging, one for production. But I'm lying because we have two. Because there was an issue there. to keep things straight, practically, you need your each application needs to belong to a project if you want to have things nice and clean and tidy. So we saw an issue there, a chicken and egg issue as always, where you cannot create the application sets if you didn't have the projects in place there. So practically we have one app that only creates the projects, and then one which is the app of apps, and eventual consistency helps us with that. Yeah, so I can show you.
So I'm not familiar with Q. Can you tell us a bit more what exactly this is and how it got integrated? Like, is it called by Argonauts? How does the integration work?
So yes, that's a great question. So the question is, how is Q integrated with Argonauts?
What does Q do?
And what does Q do? Yes, I'll start with the Argonauts part. So Argonauts, as I said, will would look at some Git repo and somehow generate some YAML code, some Kubernetes manifests, find any potential deltas with the clusters, and provision them to the clusters. The somehow part is what's interesting here. It supports customized Helm and raw YAML manifests, but practically you can do whatever you want. You can add more stuff than that using CMPs, which is an abbreviation for custom management, config management plugins, I think, I hope. And what you can do is that you can do some custom scripting there, which is what we did. We are running a command to run Q and generate the final YAML code. So yes, what is Q? Q is it's not exactly a templating engine. I am not really good to explain that. It's not easy, but you can practically you can define some structures, let's say, and practically you define the structure of the input. You create a contract. I will give you some YAML with a very, very specific format and with validation and whatever you need. And you will give me this specific format of the data I gave you. So it can transform the data in any form you want if you configure it properly, which is not easy. Yeah, I think that maybe at some point we will migrate to pure Golang, but again, it's using GoTemp. It's a language that is it's a hybrid between a programming language and Go templating at the same time. It's not the prettiest thing you've ever seen, but it's.
And other templating languages, older ones, are less capable in Q. Is that why you chose Q?
The reason we chose Q is validation. We had user data. So at that point in time, a couple of years back, Q was the only thing that would allow us to do this with validation without us using a real programming language, which, as I mentioned, might have been a better idea. But it was at least we got results fast, so yeah, and that was an issue.
Other questions?
Okay. Thank you very, very much.
Thank you.
So, thank you, Stavros. We have the presentation of Alessandro already.
Yeah, almost.
Okay. So, can I present from this laptop?
Did you send a message if you want to join that?
Yes, probably. Yeah.
And then you can present from there, or I can present.
How much time do I have?
So, Alessandro, ladies and gentlemen, Alessandro will tell us about Gateway API. And do you need like 5 minutes to set up?
So I want to do a demo because
Okay.
nothing like a demo.
So let's have a break for 5 minutes.
You want to start with the demo?
No, at the end.
Okay.
Yeah. So just look at my computer.
Yes. 5 minutes. Okay.
Also, maybe get something to drink.
How did your speech go as your presentation?
Marathon. I guess it's not your first time hearing this, right?
In Athens, no. In Greece, no. My wife is Greek.
Yeah.
So, but never comfort.
Yes.
Let's take some pictures. Post them on the CSF ambassador. If you are ambassador, you apply. And you can say,
I'll put you as a reference.
yeah, the holiday is 75%. 75% scam. That's why I got all this.
So, are we ready?
But you don't need to join now. But
I mean, I can.
Anything help?
No, just
Let me know if this one will get it out. Okay.
Oh, you can see that from there? There? Oh, you have your own? Oh, okay.
Your scroll is to go full screen.
I guess.
No, that's all you get. I think. Okay, it's gonna be all right.
It's good here.
So we do this. So people, okay. So second talk from Alessandro. Okay, he's going to tell us about the new gateway API from upstream that is going to replace Ingress eventually.
Eventually. Thank you for having me. So it's a marathon because I was at OpenConf. I got the T-shirt to prove it. Better there? Yes. And then we got into a taxi. There was no traffic. I'm surprised. I'm a bit disappointed. There is no traffic in Athens. So I came here to talk about something that I really love to talk about, which is Gateway API. So who knows what Gateway API is? Who is using it? Fantastic. So I'll give you some tips and insights. So who uses Ingress? Everybody. Okay. So by the end of the talk, maybe you change your mind. So I'm Alessandro. Before you ask, I'm Italian. I'm from the south, aka Magna Grecia. So we are all the same. We consider ourselves cousins of the Greeks. So we are. I'm from a town called Taranto. And we all talk about Taranto. The name comes from Taras, the son of Poseidon. So we are embedded and imbued in Greek culture. My lovely wife is with me, Meg. She's Greek instead. She's from Thessaloniki. What I do, I run the Dutch Kubernetes meetup. So I'm really glad to. So by the way, if you ever come to Amsterdam, we organize a meetup for you. No problem. Or you can join our meetup. Yes, we live in Amsterdam 20 years, so that's for about 10, I organize meetups. 8, I organize the Kubernetes meetup. So I've been around Kubernetes for a long time. Shout out to Christos, another ambassador from Greece. I don't know how many you are in Greece, 3, 4, maybe? Something like that. But yeah, so ambassador means we kind of can't stop talking about CNCF, and we organize local communities. I'm working on a thing called Kubespaces. If you ever want to know about it, it's a namespace as a service. It's something new. It's a startup. Me and my wife, we are building it, and we need help or feedback. So I'll be happy to give you a small demo afterwards. And I'm very proud of being part of the TAG, the Technical Advisory Group. Within the CNCF, there are these tags for network security, observability, and one of them is environmental sustainability, which is one of my interests, and I'm a tech lead for this group. So if you're interested in sustainability of software or cloud native, that's the place to be. We just meet every now and then, every week, really, and just discuss about topics about it. So you're very welcome to use it. So I remember, because 8 years, right? So I remember there was a time Kubernetes 1.0, actually, so Kubernetes just started 10, right? So, and I remember when they released the 1.0, and then we thought, but this is not ready, right? So this is still very beta. But the release team decided that that was the time to release a 1.0, but it didn't mean that things were finished or complete. In fact, even 1.1, there was no ingress. There was no way to route, there was a way to route traffic inside the cluster using load balancers and services and so on, but there was no ingress. I remember it was introduced when I was part of the community. So this was before ingress. Services were from the beginning, of course, they were part of the original commit. In fact, services are used to route traffic inside your cluster, your pods. Otherwise, what's the point of running an application if nobody can see them, right? So yes, there might be a case where you run, I don't know, some batch job that calculates some stuff, you don't need to expose it, but most of the application we run, we need to see them, observe them, we need to provide a service to somebody outside the cluster. So services were there from the beginning, and what we have to do was to attach to every single service a load balancer IP. And then consumed a lot of IPs. Imagine you are in public cloud, every IP costs a little, maybe a few euros a month, but can add up very quickly. Because every service must have its own public IP. So that was the only way to expose services to the outside world, not even to the cluster, but to the internet. So this is how services work in Kubernetes, right? So there is the staple of Kubernetes services is the service, and every service is at least a cluster IP service, right? So cluster IP is a special kind of IP. It's only available within the cluster. Only pods and nodes can talk to that IP, and nobody else. So it's useful for microservices to talk to each other, but other than that, it's totally useless. Like you can see it. It's a totally virtual IP. It's not even part of the network of the nodes, so it's just a virtual IP only available to other pods and the nodes. To actually access that cluster IP, you either need a node IP, a node cluster type of service that introduce a special port that is connected to on every node, and then builds upon the cluster IP, or a load balancer. Right? So a load balancer builds upon the node port service and allows you to attach a public IP, so traffic can go through the service IP, through the service to the cluster IP. And of course, there is an endpoint. Again, we were not talking about that because this is a classic Kubernetes networking. This works very well until you need to expose a bunch of services. Then you need a lot of these load balancer external IPs, which is inconvenient. So we introduce a thing called ingress. Ingress is a way to route traffic within the cluster to the right service using an ingress controller, which in most cases is a router or reverse proxy of various kinds. So all this stuff, it all based on all this. No, usually not. Yes. So all this stuff is based on IP tables, classically IP tables. So we're talking about 2018, no eBPF. So we only had no IPVS, nothing else. But so IP tables. So all this stuff on the left is purely IP tables. Right? So it's not a real proxy, just a trick of the IP tables that can send traffic to the right place. While ingress is an actual reverse proxy. So ingress controllers are Nginx, Envoy, things like that really do data path. No, they stay in the data plane, they intercept the traffic and make a decision where to send the traffic. And so they also introduce latency for that reason, but still gives you so many advantages, as in, first of all, more control over where the traffic goes. Things like mutual termination of TLS connection there, observability, because every connection goes to the ingress, you can measure it. You can see how many 500, 400s, and so on. Okay, all good. So this is how it works. You have an actual pod running an actual reverse proxy. It took me a while to understand it, of course, because this was for me like the most complicated things in Kubernetes before, of course, everything else, before storage. This took me some time to wrap my head around it. Like an ingress over is an actual pod, and there is a service attached to the pod of type load balancer, and then there is another load balancer in the cloud or MetalLB or some trick that you can find to get the traffic into the ingress, and then Nginx Envoy will make a decision based on your ingress resources. Ingress resources is just a definition. So I want this traffic to go there, and I want this traffic to go instead to another service. This works well, it's great. We use it. used in production all over the world. Why change, right? So why something has to change? Because there's some friction there, right? So first of all, it's complicated, it took some time to understand it. And it's one big object. Do I have the object? I'll show you the ingress object in a moment. It's great, but it lacks core features, like, for example, traffic weighting. You cannot say here, you cannot do 50% to this pod or 50% to that. You cannot do this kind of tricks because it's a limitation of the ingress controller. Not a limitation, but it's an implementation-specific feature. So because ingress is one resource and everybody has to use it, then we need to have implementation-specific features enabled via annotations. Annotations are special labels you attach to an object that influence the behavior of a controller. In this case, ingress controller, for example, Nginx, looks at the annotation of your ingress and then makes a decision. Like, okay, maybe you can, for Nginx specifically, you can do things like for example, you can do canary, but you have to use the annotations. Annotations are brittle. You have to learn them. You learn them for Nginx, and that's it. If you move to another implementation, it got completely different annotations, and that's not great. We like in Kubernetes to reuse knowledge, right? So why you have to do it twice for the same thing? So it's not great. It doesn't support more protocols than HTTP and HTTPS. So doing TCP routing with ingress is really annoying. Right? You have to go over your head. You have to do some crazy stuff to do some simple TCP routing. So that wasn't possible. Vendor lock-in, because you gotta know this extension, these annotations, and who knows if you change if you will find them in the next implementation. And it works, but could be better. So that's why we need something new. This is Chicago. No, so I think it was in Chicago indeed. Chicago 2022, maybe. Well, this was 2022. I think it was Detroit, Chicago. So it was in US somewhere. I think I was there, but I wasn't part of this group. And so somebody proposed we needed a gateway API. Not an ingress, we need to move forward. We need to introduce a gateway API. Can you tell me the time? So totally lost the track.
25.
All right, okay. So we need a gateway API, something that can do the same job as ingress, but in a better way. Specifically, we need to introduce different protocols. So now we split this ingress monolithic resource into HTTP route, TLS route, gRPC route, and gateway resources. So we split we delegate to different objects, different part of the job, which is controlling what goes in the cluster. So that's one job, what goes in the cluster, and what to do with the traffic after for the routing happens. So this is the important part. This is the genius of Gateway API. I don't have a single ingress resource. I have multiple resources. It may seem a bit more complicated, but now because they have different resources, I can make sure that my application developers can create HTTP routes, and my operator can create gateways and separate the concerns. So because these objects, gateways, HTTP routes, they are namespace scope, right? So I can tell this application developer team has rights over this namespace to create HTTP routes, while cluster operator cluster-wide rights to create gateways. So this is why many things work in Kubernetes this way. Even seekers and config maps, they are like this because seekers being a different resource, you can assign role-based access control rules just to secrets without conflating everything in one object, right? So because they are split object, now you can control the permission to it. So it's a GA, so Gateway API was born in that meeting, and then a group was formed under CB network. So in Kubernetes, we have these special interest groups. There's one for storage, one for security, and there's one called CB network. Takes care of all the networking in Kubernetes, including Gateway API. So, and I think it was a new thing. So Gateway API is not installed with Kubernetes. So you have a cluster, you don't have Gateway API, although it is part of the base Gateway API, base API of Kubernetes. But for some reason that escaped my understanding, but that's the reality, you get a cluster, and it's likely that as it comes out of Amazon or Azure or wherever, or even Kind or Minikube cluster K3S, they don't have cluster Gateway API APIs installed. You need to install them yourself. I wish it was different, but that's the reality. I mean, sometimes it's what it is. So you need to install the CRDs of Gateway API. But that should not stop you. And why you should go for it? Because now you can finally be totally agnostic towards which implementation you want to use. So it doesn't matter which ingress controller you choose. Gateway API will just work the same. It's one object to rule, one API to rule them all. You can do the same things you can do with ingress, so there's no regression there. Host-based routing, path-based, all good. But on top, you can do cool stuff like gRPC routing, weight-based traffic splitting. You can route UDP if you like easily. You could also do it before, but it was a bit annoying. And especially one thing that people always wanted. What is it? Oh, this is the logo, by the way. It does have a logo, which is this, which is subtly different from Kubernetes. Like Kubernetes logo plus the arrows. I mean, this is simple. I hope they didn't spend a lot of time with graphic designers with this, a lot of money. So, like Kubernetes, there is a version, right? So there are channels, right? So there is alpha, beta, stable in a way. But they divide in two channels: the stable and the experimental. So the stable is gateway class, HTTP route. But if you want the extra stuff, like a TCP route, UDP, and so on, actually TLS route is being promoted to stable. So it's part of the core channel. But for some, if you want to experiment these APIs, these objects like gRPC route, they work, but they may change in the future. So you may have to adapt the objects to the new when they change. So this is how it works. So you have there's a separation of concepts, right? So the infrastructure provider is the person who installs the implementation of Gateway API. Probably, maybe can even come from the cloud provider. JKE installs a gateway class, so you can use JKE load balancer out of the box. Then you need to install a gateway. A gateway is an object that defines the ingress into the cluster. So what host names and what IP addresses the cluster will respond to. And then the rest is done by developers, right? So you as a cluster operator should not concern with where the traffic goes, because application developer can create this HTTP route and attach them to gateways. But you who are in charge of the gateway, it's easier if I show you. So you create a gateway, the cluster operator creates a gateway and defines which objects of type HTTP route, TLS route can attach to this gateway. And if you are not allowed to attach yourself to a gateway, that's it. There's no way you can get traffic for these host names into your application. So you can granularly define who can use the public IPs, because those are important, right? So it needs to be controlled granularly. But then once you have the traffic in your namespace with your HTTP route, then you can decide to send it to service A, service B, you can do waits and so on. So it's a separation of consent. So, and you can see, you can use wildcards in host names, right? So you can say all example.com goes through this gateway, and you can attach an HTTP route, a.example.com, and you can do path-based routing, by the way. So you get this path, and you can send it to some service. You can get another path. You can get it to another service, and they don't need to be separate objects, but it's also better to put them in separate objects. It's up to the developers, because the idea is that developers know best, right? So they deploy the application. They know what to do with the traffic. I'm a cluster operator. I just define globally for the cluster or for that team, for that namespace, a gateway, an ingress, and then it's their job to know what to do with it. And that's how it works, right? So you can define multiple gateways. These could have actually different IPs, because these gateways, they have service type load balancers attached to them, so they are also different IP addresses. So it's up to you then to make sure that DNS works. Gateway API doesn't do anything with DNS. You still need to use tools like external DNS or just manually create the records for those domain names. Not something you get out of the box. I mean, there are tools in Kubernetes, external DNS, also graduated, by the way, recently. Graduated, so it's a CNCF graduated project. It's a very popular external DNS. I mean, I cannot live without. I install it everywhere, so it works very, very well, but it's not part of Gateway API. Actually, external DNS supports now Gateway API. You can make external DNS watch for HTTP route, DNS routes, because by default it doesn't. So make sure that if you want to use external DNS with Gateway API, you deploy external DNS with the options to watch for annotations in HTTP routes. So just make sure you do that. So this is how it works, and then you can say for every gateway, I want to accept HTTP routes only from these namespaces, or from all namespaces, or from namespace with this specific label. So you can control who can use and consume the ingress resource. This is how it works. These are who use Istio here. Istio. Virtual services, annoying, but that's how you do this in Istio. Good news, you can throw them away, but you can convert them into Gateway API resources. So this does exactly the same thing, you see. So in this virtual service of Istio, what do? You define the outside path, right? So the ingress, reviews, prods, so as we see. And then you list the rules, what to do with the traffic. So it's like the same problem of ingress. With one resource, I have to define everything. It's a bit better in Istio because Istio also has gateway APIs, and it's confusing. You know, see this API version gateway networking KNS, network istio.io v1. So Istio also is a gateway resource, but be careful not to confuse them and look always at the API version, because one is from Istio and one is from Gateway API. But they are called gateway, both of them, and sometimes it can be confusing. I'm not showing the Istio gateway here, but there must be an Istio gateway, of course, that this virtual service talks to. So this takes reviews of prod, blah, 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 / WP catalog, and sends it to rewrites it as new catalog and sends it to this host, right? And see that this is one rule, and this is the second rule. And the second rule is a catch-all. If these conditions are not met, this rule takes everything. So all the traffic doesn't match the first rule goes through this. It's annoying, a bit complicated, but what if you can do better? So we have two objects here. One is a gateway that defines defines the outside world, the outside ingress resource, and the HTTP route as a parent ref. It connects to it, attaches itself to a gateway through this parent ref. And then makes just a rule that sends traffic to the right. So this is the HTTP route, this is the inside job, and this is the outside job. So you get an HTTP route attached to in the gateway API, we also have policies. It's a bit arcane now. Never used it myself, but it's something you can look into. I mean, I will look into because I want to do some. For example, there's a policy called backend TLS policy, which you attach to the TLS route or HTTP route, and you can define if you want to do TLS validation to the backend or not. It's a bit complicated, but it's there. So they make these policies. So there are objects called LCheck policy, retry policy, backend TLS policies. They are new objects. You can attach them to objects in Gateway API, like a HTTP route or TLS route, to influence the object itself. So this retry policy will just make sure that if the connection to the backend doesn't work, you retry every now and then. It's a way to replicate what Semrush Mesh does with simple object and standardized object instead of I'm going to Istio and I need to learn Istio way of doing things. It's Linkerd is another way. So it's a way to make sure that all implementation work homogeneously. Standard channel, experimental channel, we talked about it. Should you migrate? I think you, or even better, if it's a greenfield project, I wouldn't even touch ingress. Like I'm not doing, I haven't done an ingress in a long time, but 6 months. It's a long time, right? Why you should not migrate? I don't think it's, there's a lot of reasons. There are some use cases that are not covered yet, but they are becoming less and less relevant. Can't think of anything actually that you cannot do with the Gateway API. And the thing is, the same controller supports both ingress and Gateway API. Or, for example, Istio Gateway supports, of course, the new Gateway API objects and the old Istio API. So if you cannot do it with Gateway API, well, you have to do it with Istio or Linkerd or Cilium Mesh object. But if you can stay within the Gateway API, then you're sure that whatever you are creating can be adapted to a new ingress tool, whatever, without modification. And I'll show you how. So I think it's a yes. How you migrate? This is an ingress, right? So in the same file, you define what's up, what is from the front end and the back end. And then you have to translate it into 2 resources. And of course, in the simple demo, this is done by you. You do everything because you're a cluster admin most of the time, kind, K3S, your own cluster, you can do everything, but you should make sure that these are also, well, you should also you can put them in different namespaces if you like, to separate the concerns, and you can give this object type HTTP route to your developers so they don't shoot themselves in the foot and they don't change the gateway without changing anything else. You can do also interesting stuff like here you can put like weights and please try. Interestingly, by design, you cannot attach an object in namespace A to a gateway in namespace B. You need to have this reference grant. And it's a new idea. I think it's very powerful. So something that we couldn't do in ingress is to have an ingress in namespace A routing to a service in namespace B. This was often requested, right? So I needed that, but I couldn't do it. I had to create an ingress also in namespace B. But this solves the problem because you can have this backend ref. So this object in namespace foo can refer to an object, a service in namespace bar. And this works only if you create also a reference grant for the service. So you are not allowed to take over services from a random namespace in your cluster. You have the owner of the service B in the namespace bar has to explicitly give you permission to route, to attach this HTTP route to your service. So this is very important. I love it. I like it very much, and I'm using it because then I don't need to replicate my routes in every namespace. You can do weighted routings, 50-50. There is already a Argo CD rollouts plugin, so you can deploy your application, then bring in a new version, and Argo rollout will just change its weights automatically as the deployment goes. And so you get like a slowly traffic going into your new service, right? Pointing to the new version, automatic, and you get like this progressive delivery, not just you have to go and change. Now I do 90%, then I do 80, then I decrease. No, it's all managed automatically by Argo rollouts. If you know what it is, it's pretty awesome. Header matching. This all, when I used to be a developer advocate for Istio, I was showing this. How cool is that? You can do header matching with Istio. Now I don't even need to. There's nothing special about it because Gateway API can do it. So you have Istio can do it. Linkerd does it too. So it's becoming commodity, right? So you can match the header of the request and then send to a specific backend if you like. So that's pretty cool. You can modify headers, pretty interesting as well. This is layer 7 request manipulation, right? So this is advanced use case. It's not just routing at the layer 4, like I'm going there, I send you there, I send you there. It's layer 7, like a inspection of the header of the request. This only works on HTTP route, by the way. So there's no such a thing on TLS routes because TLS doesn't have it's just a connection. It's not a layer 7 connection. Again, redirect. This is cool because you can take HTTP traffic and send them to HTTPS. So you can prevent people to talk to your endpoints via HTTP because you get this redirect automatically. Do you still need a service mesh after all? The answer is yes. Yes, you do. Yes, you do. So you still need service mesh because this is only about getting traffic into your services. But then, what about inter-service traffic? What about all sorts of stuff that a service mesh can bring to the table, like mutual TLS, observability, advanced layer 7 authorization, authentication. This is not the concern of Gateway API, so you still need a service mesh. Good news is most service meshes, except notably Linkerd, they include an ingress, right? So Istio can deploy ingress gateways, and those support Gateway API. So in one go, Istio, also Puma from Kong, Cilium as well. Cilium, you install Cilium service mesh, Gateway API support out of the box. So you don't need to go crazy. You can have everything with one tool. In case of Cilium, so there is also an initiative called Gateway API for Service Mesh Management, or Gamma, which tries to extend Gateway API also for service meshes. It's a new experimental thing. Do you still need an API gateway? So that's the idea. Yes. I'm sorry, the title should be API gateway, like COM. Yes, you do. So API gateways are a totally different game because, of course, they do much more than this, right? So Gateway API is pretty crude, like an ingress, right? So I get my traffic in, that's it. Now I can route it. An API gateway can do so much more. Chargeback of your API, API keys management, can do so much more. Things like Kong or Glue or some other API gateway, they still have a market. It's not, and by the way, most of the API gateways are now moving to support Gateway API as a resource, as a API, so they can be programmed through Gateway API, at least for what you can. And then there's always going to be some advanced configuration that you still going to need to do through, I don't know, Kong dashboard or Kong API. But most of the common stuff should be done through the Gateway API. There's a tool, Ingress Gateway. Ingress to Gateway. It's a command line tool. You feed Ingress resource and spits out the separated resources for Gateway API. So there's no more reason to not to migrate. And there's also a new tool called Gateway Control. I don't particularly fancy it because I can see the same thing via kubectl. It's not introducing anything special, but it's a nice way to have all the Gateway API objects visible through the same tool. Some people like it and they made it. This small pitch about Kubespaces is what we do. By the way, so in Kubespaces, we offer namespace as a service. And the cluster API is used everywhere. See, this is cluster API. So we expose those API servers within our host clusters through Gateway API. And I can show you. And we can do that. We can do that with one single way of doing it. So we have Gateway API. We choose Gateway API because we don't need to be implementation specific. Tomorrow I can change Envoy Gateway for Istio, and I don't need to rewrite all my objects because I already made them compatible. I made them with Gateway API in mind, and that's how we do it, right? So we expose the API of the big clusters through one URL, one public IP, and the applications also running inside the big cluster are also exposed through Gateway API through the single to a gateway that runs in the host cluster. And that's what we do. We try to have namespace as a service. I'll be happy to show you later. I don't want to do any pitch. How much time I have?
Yeah, it's 10 to 9. I think we have time.
Okay, so it's just that. So I know that it's. I talk about giving you like a simple demo. I don't know. It's can read maybe a bit bigger. And actually, I'm giving you a demo of Kubespaces. So these are our, let's say, not production. It's a big word. We are building it, so it's still. We are working on it, but it works. I mean, that's it's just not. We don't sell it yet, right? So, you know what is a big cluster? Big cluster is a virtual cluster that runs inside a Kubernetes cluster. It's made of an API server, so it looks like a cluster. It looks like Kubernetes. You interact with it through the same API, but it's a virtualized API server, right? So it's what. It's also what kind of, if you think about AKS or EKS, right? So these management control planes, they also run virtualized, containerized inside Azure or Amazon infrastructure. It's what they sell you is this API endpoint that you can talk to, and then you have to run your own nodes, of course. But the control plane is inside the cloud provider infrastructure. So it's a cluster, right? So and I use Istio system. Where am I looking at? Yes, it's in Envoy gateway system. So this cluster runs Envoy. Second, I want to spell it. So this is how Envoy Gateway looks like. I have two gateways. I can also look at gateway. So the gateways are actually running. The objects are inside this. Wait a second. Yes, I use Kubecolor, but clearly it's not great for this. So I have two gateways, right? So these two gateways are objects, right? So let me look at the apps gateway. By the way, the object lives in one namespace, and when I create this object, look, this is the specification. This is the apps object, binds or accepts all these host names. It's a wildcard, and accept protocol HTTPS. And by the way, there's the apps wildcard TLS. But they actually, it does use cert manager for that. Because, you see, there's a cert manager annotation, so the certificates will be automatically created by cert manager. So it works also with Gateway API. But what I want to do is to show you so this is the one that we just showed. So it talks over port HTTP. So it's two allowed routes. One is the HTTP to do like a HTTP to HTTPS, and one is the actual route that routes this, and the protocol is HTTPS. While my other gateway, the API gateway, is a listener that instead, the protocol for that is TLS. So not HTTP, not HTTPS, TLS. It does TLS pass-through. You couldn't do the, I mean, you could have done it in Ingress. I could have done it with Ingress with some trouble, right? So, but then I said, oh, why? I have this new gateway API. So this API pass-through is great because now I have a bunch of big clusters. So my big cluster, I'm not going to deploy a big cluster, a new big cluster, but I have a bunch of big clusters, and these are all API servers. These are all distinct Kubernetes clusters. So there's an API server, for example, in Alessandro. You can see this is the API server. Why is that? I mean, if you look into it, is just a regular Kubernetes API server. There's a service, of course, which is this one. It's a cluster IP service. It serves over port 443 my API. But how do I access those? Right. So that's what we came up with Kubespaces. We defined a TCP route. Oh, that's interesting. Okay, I can define a TCP route. So a gateway. So I can go and define an HTTP route myself, or I can do this just to show you easily how it works. Because I wasn't expecting to be chart, the cluster. Let me just quickly get to the right thing. So I thought about giving like a real thing. This is semi-production deployment. So if I need to define some things here. So cloud is scale. Application short is fra, or is meter, and tenant is Athens. All right, so just have to define this these variables, and with this, so with one Helm chart, this Helm chart deploys the big cluster and also deploys this TLS route. So it replaces the variables in this TLS route. The TLS route attaches itself to a gateway API, to a gateway. So you see now I have a big cluster, this. There should be an Athens meter, still coming up. And then I have a TLS route. This time, this is this one. Not this TLS route, sorry. So TLS route, API Athens meetup. And you notice that this Kubernetes, this TLS route exists in a different namespace, right? So how can this TLS route attach itself to a gateway that already exists and refers to a service in a different namespace? So the namespace is Kubernetes system, and okay, thank you. And there is a reference grant in the namespace. So there is an API reference grant. This is all created by the Helm chart, right? So, but I could have done it manually. And this says it's okay for a TLS route in Kubernetes system to attach to a service in this namespace. And that's why it works. And lo and behold, now, because of course we have, now the API server is up, what I can do, get secret. So I'm basically, the kubeconfig of that big cluster stored as a secret in the namespace. So you can see this courses and look at the endpoint. And the only missing part now is external DNS. And external DNS, because there is a you notice this, because of the annotations, external DNS still works with annotation, of course. Then I have my envoy system. I have my that URL that DNS names now points to that load balancer API. You see, but the point is, what is the point? That I can export my kubeconfig to be, and then I can do kubectl get pod -8. And if you don't believe me, of course, so kubectl is talking to API, Envoy Gateway is doing TLS pass-through. I'm going straight into the API server, and I'm getting a response. The certificates are fine because the kubeconfig contains the CA of the API server, and the magic is in the Envoy Gateway doing TLS pass-through. So just not inspecting anything, just saying just go to this endpoint. So I'm reaching from outside, from this Wi-Fi. I'm reaching the public endpoint of the Envoy Gateway, and I'm going straight into the pod that is part of the big cluster. And that's the demo. It didn't blow up. Thank you very much. Any questions? Any questions? Are you gonna use Gateway API?
I have a question.
Okay, I get 5 users every time.
Yeah,
Do you know if API Gateway supports Proxy Protocol v2 for the TCP route?
It's a good question. Another question. It's a good point. So TCP route. I never use it. I mean, I haven't used it yet.
Pass the source IP down.
Good point. Yeah. Good point. You can, if it's not there, you can contribute. That's the beauty of it.
Let us know.
Yeah, but it's, I never used it yet. I was dealing with a lot of pass-through TCP routes. I haven't touched TLS route. I haven't touched TCP route. But there's always some application that doesn't understand HTTP, RabbitMQ, this sort of stuff, or Postgres. So it's a good point. Yeah. Any more?
I have a question. I noticed in the HTTP route some cool things like nested rules. But
Yes.
I noticed also that you could have multiple backend rest. You could have multiple backends and multiple parent rests for some reason.
Yeah.
Why?
And flexibility. So far, I only seen Glue. Glue is this open source gateway from Solo. I used to work there, which they donate. So I don't know if it's specific to Glue, but what you can do is to delegate an HTTP route to another HTTP route. You can chain HTTP routes. There are use cases for it. Maybe you are a team, but then you have other teams and you want to give them without involving the top level team, which owns the gateway. The team that owns the gateway gives you an HTTP route ability to also delegate to other HTTP routes.
Slash product, slash gateway.
Yeah, maybe. Yeah, because then you can do more paths along the. Sometimes I feel like people do things just because they can. They say, "Oh, why not? Let's do it." But there are always some use case you can find to that. Right?
I thought maybe you could like broadcast or something to multiple,
Maybe,
like
yeah.
multicast.
Multicast, yeah, but you can do traffic mirroring already.
Like that,
Yes,
yeah.
you can mirror traffic already. Yeah, so good stuff. All right. Thank you for having me.